Good morning. Mostly. I would have had you all with me this morning, but it didn't work out. So YouTube has been improving my user experience, and apparently they just changed my streaming code. And also didn't reject the previous one. So I was just streaming into the void this morning. Screaming into the void. I was streaming into the void. Which is, I am disappointed. It was just, I felt like I was sharing some stuff with people, but obviously not. I still got work done though, so it's not all bad. I did get everything set up, and it was only for an hour or something, so, It's also my fault for not just double checking everything, but YouTube changed all the URLs for all, the live streaming dashboard and all that. So I don't even know where I'm supposed to be looking. So I'm just having a great time over here. But so I think I figured out the paddle problem. So there's been some Cherry MX paddles that I would use for on my keyboards for the buttons that are to the left and to the right of the thumbs. And I realized that I could make the thumb paddles. I wanted to make the thumb paddles attach better, and I couldn't figure out a way to do it. Well, I figured it out. Because the thumb paddle because you have a very limited mounting point, and I don't want to use glue or hot glue. I wanted to have a fitted mount where the switch itself would hold down the paddle, which is fine, but there's lever tension that happens on that, and I was concerned about that too. So what I came up with, which was awesome because that idea hit like a bolt of lightning, is connecting the three together. So the idea would be that you get those three thumb switches, and you make a base into which those three thumb switches sit, and then you solder those switches in place, and then that is your base for keeping things stable and attached. And then the whole piece has the stand-ups for the paddles going left and right. So that idea was really cool. I'd also fit it within 1U. So there were some sacrifices that I needed to make for the thickness of the paddle posts. So everything had to be adjusted a little bit, but it was totally fine. And this was all done in OpenSCAD, so you'll be able to mess around with it if you want. Although I've made it pretty modular anyways. The idea is that you would be able to... so once you generate the pieces, you can move them around however you like. And they fit in one unit of one key switch space. So I actually had the idea of making this, potentially this can fit within a fit underneath a 2U space bar. So if you have a 40% and that 40% keyboard has a 2U space bar, and then you've got modifiers on the left and the right hand side, well, that's great. But you should be able to use paddles on those modifiers on the left and right. So by making the whole thing modular and letting it fit together within 1 unit of space, or within 2 units of space, or within one square unit, it'll fit within the footprint of one switch. So it'll fit no matter what keycaps you have. So then you can have your 40%, your grid layout 40%, and have it have paddles. And this is what makes it a little bit more compatible with other boards. That said, plate mounts. If it's plate mounted, it's not going to work with this because the 3D print paddle base fits beneath the switch. So the switch has stops where it fits into the plate and stops once you push it in. Those are the stops that I'm using to hold down the paddle base, and then the paddles come up from there. So if you have a PCB only 40% or something like that, like a JJ40 or something, you can do that. Let's see what else. Oh yeah, so once I got that built up, I needed to set my layout for the Signum 3.0 and the 3.1 because I have a Signum 3.0. Well, I have both actually, but you know, that's what people are primarily interested in. And I don't have a single unit spacing between the primary thumb switch and the secondary thumb switches to the sides. So I had to figure out the actual sizing and spacing on that based off the PCB footprint, the PCB layout. And it was a solid exercise in CADing between two different systems. Also, the X and Y are inverted in OpenSCAD, and I have no idea why. But that's not important. Anyways, right. So I was able to get it built up, and it fit. And I printed up. I'm calling them. What did I call them? Not triangle. Triads. Paddle triads, because you've got 3 switches mounted into the base, and then from there the paddle posts come up. So there's paddle triads for Signum 3.0 right and left, and Signum 3.1 right and left. And I realized that the fitting it into one U size meant that the paddle was a different size. So that was what I was doing this morning on the live stream that wasn't. Was building up those paddles, getting everything to fit. So it was done. It was done pretty quick, actually. Again, that Emacs, like, you can compare the Emacs or the shorthand for OpenSCAD, the short language that I wrote, the translation language. I don't know if you call it scripting language or what. It's a language of some kind, but it's just shorthand. So the amount of typing that you have to do and the amount of syntax errors you don't have to worry about is just mind-boggling. I don't know. It's just everything works faster, everything works more smoothly, and it's just simpler. It's faster. It's easier. It's great. I love it. I also worked out a few bits of syntax where Emacs Lisp was reading stuff like dots and parentheses, and I had to escape those out, which is just fine, but it made it less pretty, but it doesn't matter. It made the shorthand code a lot cleaner, and that's what's important. What's really cool about the Emacs, the keyword system, because I'm translating all of those long text entries into keywords, and then I'm processing them as I'm converting them between strings and keywords. And Emacs doesn't care if my keyword is like / parentheses variable name plus 2.5 close parentheses divided by 5 or something like that. It doesn't even care. It's really impressive. I thought, you know, when I was first setting up this language, the shorthand language, I was like, well, you know, I could probably do this in Python a lot faster. Just make a little processor that'll read the input file and generate the output file. Just translate it. But I'm realizing that processing that code that way, I don't think it would work. I think I'd run into a lot more problems than I have with the Lisp. I don't know, maybe that'll be a fun challenge. I'm gonna write it in Python, see how it comes through. I don't know. Everything should be in Emacs anyways, because you're editing the text. You know, you have all your advanced text editing features to jump around and copy things and move them and treat the different paragraphs of text, and then you just hit a keystroke and it updates in OpenSCAD. There's no better way of doing that. The only better way I've come up with of doing that is if you make it process every single time. I could probably make it process every time I switch modes. I'll have to figure out how to do that, but then I'll have to define my own mode for it, and that'll be another journey. But it'll be worth it. It's good stuff. I mean, as I've already experienced, like, directly, this is impacting my workflow. I made a tool that made my work significantly faster. It's probably twice as, probably 3 times faster. Man, I really hated working with OpenSCAD. And after I was done today, or done this morning, my first thought was like, wow, maybe I can set up the polygon layout for the Signum and start building a case, like a proper 2-piece case. And like, I never wanted to deal with OpenSCAD to do that before. I just like, okay, I'm gonna have to wade into that, and there's all kinds of weird problems and rendering problems. Like, I don't even want to deal with it. And now with this language, it's like, this is so much. It's a breath of fresh air. So, make tools that, and that's what this was. It's cool that that's the way this worked out, because, you know, I'm like, oh, well, clearly the design philosophy needs to be adjusted. We need to be focusing only on the output and increasing the speed of your input and the speed of your feedback. Because if you can do that, then you have faster iteration times. It's easier to tweak things and adjust kind of on the fly. And then with less syntax, just in general, not only is there less typing, there's less stuff for you to look at. So it's a lot easier to not get lost in those, you know, the parentheses within the square braces, within the parentheses, within the curly braces. You know, that's the proverbial coder's dilemma, is you spend 15 hours on something, and then you find out that it was just a square brace where there should have been a curly brace or something. It's something simple like that, and it's like, why is this even a thing? Why am I even bothering with this? Why syntactically am I going to take advantage? Am I not going to take advantage of this preprocessor by just using white space? It's because the lines get too long, so shorten the lines, you know? I don't know. I also made shorthand variables, because I normally use very descriptive variables and use autocomplete in my editor to fill them out. But in this case, I stuck to shorthand variables. So I would write paddle underscore width equals whatever, and then I would write a new variable, pw equals paddle underscore width, so that I could use either. And everything still remains somewhat descriptive. You know, you can look back and see what it actually is, or what it's pointing at. But it's like pure rubber meets the road. It was great. I also got I got the Raspberry the Raspberry Pi 400 came in yesterday, and I updated the card and got the whole thing updated with a bunch of software and some learning stuff for the kids, and it's actually more computer than I want them to mess around with right now. Right now I have them kind of messing around with it's called Ichigo Jam. I actually don't remember how much I've talked about this, but it's a 8-bit computer system based on well, technically it runs on a smaller microcontroller with a composite video out, but you can also, there's a version that runs on the Raspberry Pi with the ARM processor, that's pretty impressive work. And it's very, you know, it's simplistic. It's kind of like one of those virtual consoles. What is it? Fantasy consoles. It's like when they made an 8-bit gaming platform as a imaginary console, Pico 8. But in this case, it's a computing platform. So you get, basically, it's like a kind of a Commodore 64 style interface with basic programming language, and then you just kind of mess around with it, and you get full control over everything. So you get full control over the character set. You know, you can poke and peek the memory to your desire, and you can, much like Mr. Davis, the late Mr. Davis, said, it's like a motorcycle. If you do something stupid on a motorcycle, you will lay it down. You will go flying. So you got to know what you're doing and learn from your mistakes. And the thing runs on a $5 Raspberry Pi Zero. It's a 0W, not that it matters because it doesn't have Wi-Fi. You just plug a keyboard into it, plug it into the TV, and you get HDMI out. I think you get the standard display is supported, and then composite video out is also supported, which is kind of cool, because I wired up the composite video so that it looks all greeny and it's just really something. And the kids had fun, you know, made a game, and then they were playing the game, and they're like, oh, it's a little too hard. And I'm like, well, actually, this is our computer. We can do whatever we want with it. So let's open up the code for the game and then change it and make it slower. And I showed them how to make it slower. And then next thing you know, they were typing list and then navigating up to the wait command, and then improving or increasing the time, then trying it out. And they're like, oh, wouldn't it be better if we could keep score? Like, yeah, let's keep score. Da-da-da-da-da-da. Now we're keeping score. I still haven't figured out how to do, well, there's a few ways to do it, but not quite sure. There's still obviously hardware limitations, and the limitations are what impart the creativity. You know, you run into more interesting challenges, and you have to think about things in different ways in order to produce what you would want. Whereas if you just had unlimited resources, you know, who cares? You can do it however you like. It is something that I wanted to get. You know, if the kids like it and use it well, I might upgrade to the color Maximite, because I've been thinking about that for a while. I didn't have a primary use for it myself, but the kids certainly would. All right.